Today we have two slight risk areas for severe weather in the northern plains and the northeast, and we have a marginal risk in the Midwest. Good morning, I'm meteorologist Pew, and today is July 3rd, 2025. Today the primary threat is high winds and large hail. Specifically for the northern plains, they could see winds up to 85 miles per hour and hail up to 2 inches in diameter. There's also a small 2% risk for tornadoes also in the northern plains. The northeast is going to start seeing storms first as early as 11 a.m. to 1 p.m. Eastern time. States like upstate New York, New Hampshire, Vermont, Maine are going to see it first. And then later in the afternoon into early evening, downstate New York, Pennsylvania, and New Jersey are going to start seeing something around like 4 to 6 p.m. Eastern time. But North Dakota won't see any severe weather until around 6 p.m. Central time. And those in the marginal risk in the Midwest, mainly in Wisconsin, won't see anything until around like 12 a.m. Central time and through the night. 500 millibars or midway through the troposphere, we have a really great jet streak that's coming through, and that's going to provide really good wind shear, and that's going to tilt those updrafts, prolong those storms, and really enhance those thunderstorms to form. And this jet streak is located at the bottom of this major trough, and that's really important because if we look at these lines of constant pressure, you can see them kind of spanning out a little bit, and that's a really good sign for upward motion. You can kind of think of it as air spreading out and letting the air from the bottom rise up, filling that space. We're going to have a cold front that stretches from Canada to the northeast to the Midwest, and that's going to be the main driving force to lift those surface airs. If we look at the satellite imagery right now, we can already see that there are clouds covering some areas of the northeast, but areas that don't have any clouds are going to have a much better chance of producing thunderstorms. Taking a look at the northern plains, they also have some clouds covering the area, but that will eventually move over and allow for some diurnal heating. Looking at 500 millibars, unlike the northeast, the northern plains don't have that much going for them. They don't have a trough, don't have a really good jet streak. Their wind speeds are mid, so that means their wind shear is also mid. But if we look at the raw data, it's a little crazy. Okay, so this is a sounding. This is what meteorologists use to figure out what's really going on. And I know it looks a little crazy. All you gotta know is that the red line is temperature, green line is dew point, this dashed line is an air parcel and how it's reacting to the environment. And then these weird lines to the right are just wind barbs. The lines are turning a little bit more clockwise, and that's a really good sign for rotation and spin. And that's gonna help with the updraft, which is gonna enhance the thunderstorms. Now this sounding is from the models and not from an actual weather balloon, so things are a little bit theoretical. So if we're looking at the air parcel, when it gets to this point, that basically means that the parcel's temperature matches its dew point, which means it's saturated, which means condensation is going to start occurring, which means clouds. The area between the air parcel and the environment temperature is going to be what we call CAPE, or convective available potential energy. So basically the fuel of the storm. And based on this sounding, that CAPE is really high. Because the surface temperatures are so hot, that makes the lapse rates a lot more steeper. So if we get more sun, more heating, that's going to make the lapse rates even steeper, which is going to give us more CAPE or more energy.